Today, in this video lecture, we will see numerical 2 on design of shaft. Numerical is a shaft transmits 75 kW power at 120 rpm. Determine the diameter of shaft if allowable shear stress is 50 Newton per mm square. The twist in the shaft not exceed 1.5 degree in 5 meter length. Take G, shear modulus is 85 kN per mm square. Write given data. Shaft transmits 75 kilowatt power. P is 75 kilowatt. (75 into 10 raised to 3 watt). Length is 5 meter. That means 5000 mm. Number of revolution denoted as capital N is 120 rpm. Revolution per minute. RPM is revolution per minute. G is shear modulus 85 kN per mm square. That means in Newton per mm square, multiply it by 10 raised to 3. 85 kilonewton per mm square. That means 85 into 10 raised to 3 Newton per mm square. Only this kilonewton, convert this kilonewton into Newton. This mm square is same. And for conversion of 1 kilonewton is 1 kilonewton into Newton is multiplied by 10 raised to 3. Let me see here. 1 kilonewton is 1 into 10 raised to 3 Newton. And if allowable shear stress is 50 Newton per mm square. That means this shear stress does not exceed 50 Newton per mm square. Determine the diameter of shaft if allowable shear stress is 50 Newton per mm square. So, the shear stress is not greater than 50 Newton per mm square. It is only allowable up to 50 Newton per mm square. And the twist in the shaft not exceed 1.5 degree. So twist also only allowable 1.5 degree. Twist also not greater than 1.5 degree. And convert this degree into radian. 1.5 multiply by pi by 180. Multiply by pi by 180 for conversion of degree to radian. And this is 0.0262 radian. So we have to find out diameter for required for that shaft. So we will find first diameter based on shear stress and second diameter based on angle of twist, because we have both terms. We have shear stress also and angle of twist also. And first we will find torque using power formula, because here we don't know torque. Problem statement is to find diameter for that shaft as small d. So we will find first torque by using power formula. So first step is to find torque by using this power formula, and power formula is P is equal to 2 pi nt upon 60. And power is 75 into 10 raised to 3 watt. 2 as it is, pi as it is, number of revolution is 120 rpm, and t is t, we have to find t 60. So t is 5.968 into 10 raised to 3 Newton meter. And convert this Newton meter into Newton mm, multiply it by 10 raised to 3. So this is torque. Now next step is diameter based on shear stress. This is formula for torsion. T by J is equal to G theta by L is equal to tau by R. And diameter based on shear stress, that means this term we have to consider. And we know this T also and J also. For that shaft, J is pi by 32 into D raised to 4. To consider this first and third term, T by J is equal to tau by R. And we know that T is equal to tau into ZP. Polar sectional modulus is equal to T by tau. So take this RHS tau shear stress to this LHS. So T by tau, simple mathematical calculation, T by tau is equal to J by R. And T by tau is ZP. So this term is ZP, polar sectional modulus. This T is 5.968 into 10 raised to 6 Newton mm. 5.968 into 10 raised to 6 Newton mm. And this shear stress is this 50. And this J is polar sectional modulus is, for that shaft, circular shaft is pi by 32 into D raised to 4, and multiply by this R, radius is diameter by 2. That means by mathematical calculation, this D by 2 is like this 2 by D. This 1D get cancelled. So this equation becomes 5.968 into 10 raised to 6 upon 50 is 119360, and this ZP is in mm cube is equal to pi by 32. That means this 2 is 16, pi by 16 D cube. And from here, this D is equal to 119360 multiplied by 16 upon pi and raised to 1 by 3 is 84.7 mm. This is diameter required for that shaft based on shear stress. Now next case is we will find diameter based on angle of twist. That means we have to consider this term and this term. T by j is equal to g theta by L. This is case 3. Diameter based on angle of twist. T is 5.968 into 10 raised to 6. This 5.968 into 10 raised to 6. This J is J we have to calculate first. See, J is pi by 32 multiplied by d raised to 4. G is shear modulus. This 85 kilonewton per mm square. That means 85 into 10 raised to 3 Newton per mm square. This theta is in radian 0.0262. And here is 5000. After solving this mathematically in calculator, so D is equal to 108.109 mm. See, by using angle of twist, diameter is 108.109, and by using shear stress, diameter is 84.7. So we consider same diameter, greater diameter among above two cases because of safety purpose. So D is 108.109 mm. So see this numerical. In numerical, they have given us power, length, number of revolutions, shear modulus, shear stress, angle of twist, and by using this all data, we have to design diameter for that shaft. And by using this power formula, first we had find out this torque, and by using this torque formula, relationship between torque T by J is equal to G theta by L and T by J is equal to tau by R. But that means by based on shear stress and by based on angle of twist, we had find out this diameter, and based on shear stress, diameter comes minimum, and based on angle of twist, diameter comes maximum, and we had consider maximum diameter because of safety purpose. And this maximum diameter we had get from this angle of twist. So thank you very much.